Okay, so today is day three. Sorry, today is day five. Ha! Day
Yeah.
five of Python programming, but it's week three. All right, week three, day five. We're going to look at functions. So let's check out the curriculum. If I go into functions, we should be able to see our PowerPoint slide and go from there. All right. So, like I said, we'll try to run through this very quickly and see what exactly is a function. So a few things that we'll talk about that we need to achieve before the end of this class. We'll talk about the basics of what functions are. We'll also talk about, oops, I keep moving that. We'll also talk about built-in versus user-defined functions. We'll talk about what it means to define a function or call a function. We'll actually do all of those as well. And differentiate between parameters and arguments. Those are really very easy to confuse. And finally, we'll talk about void and fruitful functions. Fruitful functions just return stuff. Void functions don't return anything. So all in all, you should be in a better place to understand how all of this works together. So big picture again, we'll be able to learn how to define and call functions, and then we'll also learn how to use functions with various types of return values. So functions are very important because it makes our code modular. That means you can take your code and turn it into a module. So just like we said on our first day, how we broke down variables, statements, and then getting to functions and modules where you actually have a compact piece of code that can be reused, a module that can be imported, and so on and so forth. All right. So let's dive right in now. What are the basics of functions? So as you can see in the diagram right here, a function is pretty much more or less like a black box, right? It accepts an input and gives you an output. Okay, so you put something into a function and it spits something else out. Again, not all functions take inputs. Some functions do not take any inputs, they just execute and give you an output. For instance, a function to get today's date will not need to take an input, it's just going to give you an output. Other cases, functions take inputs and they don't have an output. That output, like we said just recently, is a return value. Okay, so it depends on how you want to use your function. And again, you might have one or two inputs, you might have one or more outputs. It all depends. It gets, very, very versatile when you look at it in place. But in real English, a function is just a group of statements. Anything that you know that you do repeatedly, you can group the tasks together to become a function. For instance, if you know that every morning I'll have to give instructions to the kids or give instructions to someone and say, hey, get up, make up your bed, brush your teeth, shower, make breakfast, clean the dishes, eat your food, and then go to work. If you do that every day, you can, rather than just repeat those statements or those instructions, you can have one instruction that encompasses all of that. Get ready for work means do all of those instructions or do all of those steps. And if you decide to start having an input in there, you can decide to be more specific and say, Adolf, get ready for work. Aaron, get ready for work. In that case, you're passing in Adolf and Aaron in there, so they're going to do it differently. All right. And you can also make sure that you have a return value, which we'll talk about in short. So that's in a big picture what a function is. Does that make sense to everybody? So rather than, having to have those steps each time, you know, for instance, the print function is a series of steps. It could be one or two or three statements put together, but just grouping them makes it easier. Why do we need to do that? Okay, there are many benefits, as you can see. It makes your code simpler. Okay. Also, you're able to reuse your code. You don't have to repeat it each time. Last week, we had to repeat some codes in a few places, but once we start working with functions, all you have to do is define your function and then call it when you need it, and then that's it. So one thing that we'll not cover too much in our class in our program or in this program or course is testing. But testing is very important. It's imperative for you to test your code before you ship it out. Okay. But with functions, it's easier for you to test it because functions are expected to do one thing and one thing only. That's why they call them modules. So you want your function to have what is known as SRP, single responsibility principle. If your function does more than one thing, break it into separate functions. We'll talk about those as well. But it makes your development faster. So if each person is working on one function, you already have a function, no need to recreate the wheel or reinvent the wheel. You can go ahead and just use that function that has already been created. For instance, we have never had to write a code that should explain how the printing process works, but we know that if we use print, it also just executes and spits out what we put in there as an input on the console. If we use type, it tells us what type of data we entered in the parameter. If we use input, it is able to get our input and then do whatever computation we need with that. So it makes our development faster and also facilitates teamwork, because when you know that you're supposed to build this wonderful application or software, you can tell this team to work on this function and that team to work on that function. Each team works on separate functions, and then you can now merge it into one piece of application or one piece of software to be able to ship it out. So each piece of each team works independently, but then you can merge it all together. Sounds good? So think of a big picture there. If your team is working on a particular function, all they have to do is define that function, save it in a file, put it in a folder. Another team works on their own file, put it in that folder. All those separate files are in one folder. That becomes a package. So that package has several modules in there. The modules are each of those files, and then you can package them together to ship it out as a library. Okay, so that's in a nutshell what a function is. So let's take a look then at some examples. Okay, because there can be two types of functions in Python and in most programming languages, in short. Okay, you have built-in functions. These are functions that are included in Python. When you install Python, CPython, or whichever version of Python, oopsie, that's not what I want there. Let's go back to that. There you go. Sorry, I think I'm opening Visual Studio Code and then it went ahead and overtook my screen. That's not nice of you, Mr. Visual Studio. Okay, so when you install Python, CPython, or whichever particular distribution of Python, it comes with a set of functions already in there. Those functions help us solve common problems. For instance, abs would give you the absolute value of any number that you enter in there. Okay, bool will tell you whatever the value is. str, where is it? Right here, it's going to give you the string representation of that value, and so on and so forth. Max would give you the maximum in that value. So you can convert a number to a float by using the float, and so on and so forth. Length, len, which is short for the length of anything, gives you the number of records in a particular set, and so on and so forth. So those are built-in functions in Python that you can use whenever you need them. You don't need to recreate them. But that's not all that we can do with Python. We can decide to define our own functions, to create our own functions. If we have to create a function, there's a particular syntax for that. Okay, as you see right here on the right, you can define your function by starting with the def keyword, which obviously means define, right? And once you use that keyword, you have to give a name of your function. So imagine that you have multiple instructions that you have to be executed. You have to give those set of instructions a particular name. When you say that name, that's what you're referring to. Also, remember, just like our variables in the past that we talked about, those function names per se have particular rules. You cannot start it with a number. It's case sensitive, so you have to be careful how you're using the function names, and you want to make sure that it doesn't start with special characters and so on. So all those different naming rules. You cannot use a keyword to be the name of a function, and you want to be very careful because it's very discouraged to use the same name for a function as the name of a variable. So let your functions have some mnemonic names that mean something. Most of the time, it's advisable to have your function to have some kind of a verb in it, what it does. Okay. So again, having function 1, function 2, function 3 will not really be helpful. All right. So give your function a name. And after that, you have parentheses and a colon. The parentheses are used to hold your parameters, which we'll talk about shortly. The parenthesis holds your parameters, and then all of that line, that first line, is known as the header of the function. Just like we talked about earlier when we looked at if statements. And we said the if statement was a compound statement. Just like the if statement, the definition of a function is a compound statement. So when we end with a colon, we go on to the body of the function. The body of this function now has multiple instructions in there. It could be one, it could be many, and so on and so forth, depending on what you want to do. And you want to make sure that the body is indented. And if the function is having an output, if it has a return value, then you want to end with that return value out there. Okay. So make sure your block of statements are indented. After that, you're done. So it's as easy as that. Very simple to create a function that does anything. But you have to take note. Creating a function is like defining that function. It uses a compound statement, but that's all you're doing. You just created a function. In order for you to use it, in order for you to execute it, you have to call that function. To call the function, you have to use a statement. So we've been calling the print function, we've been calling the str or stir function for string. We've also been calling the input function to be able to enter user input. So all those are ways that we can execute a function. What questions do you have so far? Any questions for me? Yes, go for it.
The return within the function, can you provide some context, because I've struggled a bit with that, and it looks like the knowledge I have right now is kind of random.
Excellent, excellent. So that's something that I wanted to take time to talk about it after our break, but let me give you an idea on that. What I mean, let's go ahead and see if I can open up Visual Studio Code here. Close that. Actually, I shouldn't open Visual Studio Code. I should go in with oh, that's fine. I already have that. So day 5 needs to be created. Let's create a new code. So go ahead, Aaron. You have a question?
No, I just asked. Let me.
Okay, I saw your hand was still up. That's why. All right. So day 5. Let's open a new file, and then I'll call it functions.py. So a function, again, we said we can go ahead and call a function by you just typing it out. So let me drag this to the side. There you go. Can you guys see clearly? I hope so. Okay, good. So first, let's see, type. Let me create a function or a variable. Let's say my variable, and I'm going to call that 35. And my second variable, I'm going to call that hello. So if I go ahead and do type, my variable. Let's see. Okay, it will not help me out here. And execute that. Oh, this is not nice. Let me go ahead and make this bigger. Okay. So it executed, but nothing showed up. That's because I did not print it. So in order for me to do that, I need to print that and execute it. Never mind. Why do I have an error in here? There you go. So it's printing that it's of type integer, right? I think the first one printed, it was just delaying. And if I do the same for my second variable, that would give me, oopsie, copy that. Oh, I went and pasted instead. This should be my second variable. First variable gets printed and second variable gets printed as well. Run this again one more time. So it tells me the first variable is of type int and the second variable is of type string. So here is an example of calling this. But if I want to define a variable, or should I say a function, I start by using the def keyword. The name of the function, let's say enter input. Let's say that's the name of my function, right? After you enter the name of your function, which is unique and has to have the same, should I say, rules that you use for creating a variable, I'll go ahead and use opening and close parentheses. That tells me I don't have any inputs. We'll talk about parameters and inputs later on. A colon then means that's the end of the header. Now I get into the body. In the body, I want to go ahead and say user input should be equal to, now I use that input function and type in, so let's say enter value. So each time I run that function, it's going to execute that line of code. When that line of code is executed, I might want to go ahead and print it out. So if I want to print it out, what I'll do here is, see, type in print, entered, and user input. So now I'm printing that out. In this case, I'm not returning a particular value, okay? So this is just a regular function that takes in no input. It does these two instructions. It prompts the user to enter a value. Maybe I want to go ahead and do something else with the value, right? Print the value, maybe. And after doing that, maybe I want to convert it, right? Say you want to convert it to a number. Convert to integer. Now I would say integer user input. So that converts it to an integer. If I went ahead and say I want to assign it to a particular variable to hold that value, then I would say integer user input should be assigned to that. Does that make sense what I'm doing so far? Awesome. So we've done three things here. We have gotten the user input, we've printed out the user input, and we've converted it to an integer. We are not returning anything. So if you go ahead now, after creating this, you might want to call the function. If I want to call that function, all I have to do is to enter input, and then that function is going to execute. So let me go ahead and comment that, call or execute. Does that make sense? So now let's try to execute this function. Let me make this a little bit smaller. There you go. So if I execute that, it's asking me to enter a value at the bottom right here. Let me drag this up. My value then is 25. It tells me you entered 25. So this is not technically a return. This is an instruction that's executed. If I comment this out, nothing is going to be printed. Okay, so let me also go ahead and comment these out. So now I've commented those. I have just my function definition and the call of the function. Let's execute that. Actually, I want to clear this screen. I don't like it to be too full. Okay, let's execute that. It's asking me to enter a value. Let's go 56. Nothing gets printed. But if I want to return a value, then at the end of my function, I need to use that return keyword. Now I can decide what will be the output. After you've done all these things, maybe I want this to be the output, an integer. I want you to enter a string and then I output an integer. Okay, so if I want that to be the output, then I'll go ahead and simply put that in there. Now my function now becomes, oops, let me undo that. What does the function do? Gets user input and outputs an integer. Does that make sense? Everyone, does that help?
Yes, yes. I think, if I may, is it right to say that without the return in the function, you cannot call that function and assign it to a variable?
Exactly. So now that we have a return, if I execute this, even without printing it, it's going to print out this value which is returned. And then I can go ahead and assign it to something and use it as an input for something else.
Because the confusion I've been having,
yeah,
again, I have no clue in this stuff.
That's okay.
It's that if I don't have the return within the function, when I assign it to a variable, it doesn't do anything.
Exactly. It doesn't do anything if you don't have a return in there. So right now, I can go ahead and say, assign this to a variable and say, this is my input. Oops, see input. And it's going to get whatever is returned from this execution is going to go in there. Okay, but now I'll tell the user to enter something. What does this function do? This function gets a user input and outputs an integer, which means this will become an integer. Okay, so now I'm actually calling this function. The output gets assigned to this variable. But you definitely need that return value. So there are two types of functions. I didn't want to get into this now, but that's fine. We're already in there. A function that gives you an output usually has this return function. and that is known as a fruitful function. Okay. So that fruitful function has return value. What we looked at earlier did not have a return value. If I can spell correctly. So fruitful function has its return value. Otherwise, it would just be gathering a bunch of statements together that does not give you a return. Question, Fabian? You're still on mute.
Sorry.
That's okay.
Prof, I think I'm missing a point and I'm struggling to catch up with my brain, and
Okay.
you are progressing. I think I would need you to pause a little. So
Yeah.
you see on line 8 where you're defining the function. I understood from there all the way where we are on line 19 before we added the return thing.
Yeah.
There you said if you were to execute it, it would like print, even if you don't put the print there. I was waiting to see how that will work before you add it, because I had a question there, like if it can print like the output without you adding print to it, then there is no need for us to be using like print in those areas, right? Like there are two functions now. Yeah.
Excellent. Yes, I did skip that part because I commented it out. It's not going to print actually. That's what I meant to say. So let's go ahead and do that. So now we have gone ahead and prompted the user. We are no longer printing it. Oops. But we are converting it. So let's go ahead and call this, right? If we call that, it's going to ask us to enter a value. Let's enter 59. Nothing else happens. Does that make sense? So it doesn't print because we commented out that instruction. The only time that you have output from a function is when you're printing it to the console, but printing it does not mean you're assigning it to a variable. It cannot be assigned. This just takes in, let me go back to our slideshow here. So what this does is it takes no input. The function just does a set of tasks, right? And this set of tasks are task number 1, get user input. Task number 2, convert it. In order for us to get this back in an integer, we need to return it. So that's the difference between a void function and a return function. There are some times that you might need to have a bunch of things take place without you having any particular output. But in that case, most often, if you don't have an output, you definitely need to have a print statement to at least let you know that, okay, your execution is done, your function is done, and so on. Does that make sense?
Yes, I have 2 more questions here.
Go for it.
Now, if we were to add print to the value in line 22, will it print the output of that 59 now?
Very good question. If we were to add print in here, would that work? What do you guys think? Without us having this print in here.
I think it's not going to work. Now, this is just me thinking aloud. It's not going to work because when I look at a function, I see a box that you put something and get something out, right?
Exactly.
Now, in this case, it's telling me that there is nothing that it has to give out.
Definitely. So that's the thing, that's a very good question. If I go back to that screen I just showed you, we have no input, the function does stuff, and there's no output. When there's no output, you have a value of none. So if you see when I put my mouse over it, it tells you that's a function, it's defined as this, and the output is none. So if you print that, your output would be none. So let's execute that. It asks you to enter a value. The value is 99. The output is none. Does that make sense?
It makes sense. So at this point, where does that 59, where is 99 at this point? Like it's just stored somewhere in the storage, in the memory?
Very good question. Yes, it stops somewhere in the memory, and that's something that we're going to talk about very next. Okay?
Okay.
Excellent. I'm going to leave this here. We'll come back to it. And I really like those questions. Those questions are very, very important. So definitely printing it, this output's none. Output is none. Let me use capital letters. If no return type. So let's go back to our PowerPoint and carry on from there. Very good questions. That definitely solidifies what I'm about to say next. So let's go in there. We've looked at, the basics of a function and the benefits. We've looked at how to create a function and how to execute it. The main thing now that we want to talk about is the parameters. Parameters go into parentheses, okay? So whether it's built-in functions or it's user-defined functions, you have to have either a parameter in it or no parameters. So you can have 0 parameters, you could have 1 parameter, you could have multiple parameters even, depending on the case in point, depending on what you're trying to do. So for instance, when you're saying get ready for school, that means you have to put a parameter in there. If you have 5 children and you say, Mary, get ready for school, Mary will go ahead and get ready for school. Everybody else will not. If you say Mary and John, get ready for school, both of them will get ready for school. If you have 2 children or if you have 2 teams and you say Chelsea play against Real Madrid, those 2 teams will be playing each other while everybody else is not playing, right? If you
Real
say,
Madrid is going to win.
Exactly, right? So it depends on what you're looking at. Just in this example, right? You have defined a function. You define a function, the name of the function is add. You're giving in 2 parameters, A and B. And now you're returning a value saying that A plus B. Each time you write this function add, and then you put 2 numbers in there, it's always going to give you the sum of those 2 numbers. So this is how you would call the function. You type in add 2 and 3, that's going to return 5. Does that make sense? So in that case, you've created the function by defining it. You gave 2 parameters. Parameters go into parentheses. Parameters are what you use when you're defining, when you're creating the function. Arguments are what you use when you're calling the function. So let's take a step back though and go back to our variables. The variables usually have a scope, okay? So what we have in here, the question that Fabian asked earlier, what happens to this user input? This user input is only alive within the scope of this function. After this function is done, the user input is wiped out. It is a local variable. The same with this integer user input. It's only valid within this function. That makes it a local variable. If I go out here and I try to print it, let's say print user input, it's not going to work. And you can see it's already having a yellow squiggly in there, yellow underline. If I put my mouse over it, it tells me user input is not defined. User input is not defined because it's only alive in here. So that will give me an error message when I run my code. So let's execute that. Enter a value 77. Oops, wrong place. Let's go back there. 77. And it gives me an error. The name user input is not defined. That's because it's a local variable. It's only alive in the function. Does that make sense? So let's go back in there. Excellent. Nope, that's not what I want. Okay, so what I need is, let me put these side by side. I think it's going to be better if I do that. Okay. Excellent. All right. That way I can test it right when I'm typing it. Awesome. So we've talked about the local variables. What about the arguments? Let's drag this. The argument is the data that you pass into the function when you call it. Meanwhile, the parameter is a variable that receives that argument. When you pass 2, 2 becomes A. When you pass 3, 3 becomes B. Okay? So those are the two things that most people usually get confused in programming. They said, okay, you need to change your parameters. If you need to change your parameters, that means you need to change the definition of your function. If it says your arguments are incorrect, that means you need to change the arguments that you enter. Okay? So parameter variables are also only within this scope. You cannot take A and use it outside in your code. It's going to give you an error. But in some cases, you have global variables and global constants. Global variables and global constants would be something that you define outside the function. Most of the time, they write them in capital letters. So let's say constant, for instance, let's say name can be set to John. That's always going to be the name no matter what. So that's a constant, as you can see when you put your mouse on it. That's a constant. It's always good anywhere within the definition of the function. You can use it. Outside, you can use it. If I go ahead and type in name in here, oops, let me select all of that. It's going to print out John, regardless of anywhere I use it. So that will be a constant variable. We'll look at some examples when we get back after lunch or after our break. Sounds good? So this example also uses 2 arguments, okay? We're using multiple arguments. In some cases, you might use 1 or more arguments. In other cases, you might use keyword arguments. So keyword arguments are very, very important. So you can decide the name of your argument and then give it a value. So let me go and try out an example of a keyword argument. Does everybody understand what I mean by keyword argument? Okay, do we have any questions on that?
I guess when we see the example, it will make more sense.
Okay.
Because it sounds like it's a global variable in a sense,
okay.
But
All right, so let me go ahead and see if I can give an example of a keyword argument here. So for instance, let's make this bigger actually. Where's my, there you go. So for instance, let me go ahead and open a new file here. I'll call it quags UI. So keyword argument is commonly known as quags. Let me quags equal to keyword. So for instance, we did write a program that was able to calculate salary, right? So what were some of the things that we needed to calculate the salary? So if we want to write a function to calculate the salary, some of the things we'll need is the hours that we worked. Then we need to also get the pay rate, right? So let's go ahead and write a function that does that. Okay, so let's say define salary. The salary should be able to take 2 things. Hours worked. Oh, I cannot type. And pay rate. Those are the 2 arguments that are going to be entered in there. Does that make sense?
Yep.
All right, so if that's the case, then we know that our salary should be equal to hours times pay, right? And then all we need to do is, if those two are the inputs, our output should be the salary, right? Something as easy as that. But we have to accommodate for overtime and so on and so forth. We can set that up in here if we like, and so on and so forth. But a keyword argument will be in a case where we want to say the user has to have a particular pay. So if we go ahead and say pay equal to 20, that means.
Prof, let me just plead with you.
Yes.
I'm really trying so hard to understand this thing.
Yes.
Can you use a different word for the function name and the variable salary so that?
Very good.
Yeah, thank you.
Very good. Very good. So
yeah, you're calling out for his own stuff. Yes.
That's very good, because you don't want to use the name of a function and the name of a salary. That's why I said it's always good to use a verb in your function. So in here, the better way to have this would be calculate salary.
Yeah.
Because that's what you're doing. Does that help out, Fabian?
Zen of Python.
Exactly. Zen of Python. Yes. You definitely want this to be a verb. Calculate salary would need the hours and the pay. In this example, the pay now becomes a keyword argument, which means the pay is also optional. If I run this, if I call this and I don't enter a pay, then what I'm doing is I'm saying the pay is 20. Does that help out?
So that's like a default.
Exactly.
Right?
Exactly.
Okay.
It's a default.
Boom. It just makes sense now. Okay.
Right. So if I go ahead now,
okay.
After creating that function, if I want to use it, I have to call it. To call it, let's say calculate salary. I can go ahead and enter. Now it's asking me. Hours can take in any value. The pay has a default of 20. And then your output can be anything. So if I put in hours as 40 hours, what do you think the result would be?
40 times 20.
800.
We might have an error in here. Let's execute that and see. What am I missing here? Did I save it? Let's go ahead and clear this. All right. So let's execute that. Doesn't look like it works out for us. Now let's go ahead and try 40 and 10. Execute that. It still did not return anything. That's because that's why. Because I'm not printing it out. So let's go ahead and assign this to a variable and then print out that variable. Let's say your salary should be equal to that. And then we want to print your salary. Yeah, I keep forgetting that I'm not in Anaconda notebooks anymore, Jupyter notebooks. So let's execute that. Now it tells me 400 is my salary because I entered my pay as 10. If I went ahead and took that out and executed it, it's 800 because it's using that default value. Okay. So I can go ahead and update this and say regular hours and also have overtime hours. Okay. So now I'm getting 3 inputs: putting your regular hours, putting your overtime hours, and putting your pay. Does that make sense?
Yeah.
So your salary now would be equal to your regular hours times your pay. Let's go ahead and add your overtime, right?
Yeah.
You need to also have your overtime hours times your pay multiplied by 1.5. So if your overtime hours is 0, then that's fine. We can also set our default overtime hours to be equal to 0.
Yeah.
Does that make sense?
Yeah.
So now if you want to execute this, it's going to say 40 is your regular hours, overtime hours is 0, pay is 20, and we should still be fine.
Mhm.
But what if I had overtime hours? If I have to enter overtime hours as 10, is that going to work?
Overtime hours is 10. I think it's gonna work because of the position of that argument as well.
Okay, but we have 3 arguments and it's taking 2. So it might
Yeah.
give us an error if we
So-
execute that.
Yeah, okay.
It gives us 110. So it definitely works because of the position.
Yeah.
So a few things to note. You want to make sure that all your optional parameters are at the end of the code. Otherwise, if you have them in the beginning of the code, you might have an error. So let me get this out of there.
But it also took the pay, the keyword in the pay, and used it, all right? Since even
Exactly,
though
it took the pay and used it. Okay. So
Mhm.
if I write my code, does that clarify for you, Fabian? So it took
yes, it does.
yeah, so definitely it knows that the first, second, the last one is omitted, so it's going to take 20. That's why it took 20 and it took overtime for 10. Out of those 10 hours of overtime, you end up having, I don't know, $300. $300 added to the 800 that you did originally gives you 1100. Okay. But the one thing that I wanted to point out is make sure that when you're typing in your arguments, your optional parameters always come at the end. You cannot start with an optional parameter and then you go ahead and input another parameter before going back to an optional parameter. Okay. So as you can see, that tells me there's an error there. Sometimes when you have these errors, if you're using an IDE like Visual Studio Code, it's good to click on that view program and it tells you what the problem is. So this blue view problem option right here, once I click it, it tells me your Quartz has one problem. Non-default argument follows default argument. So that's a default argument. It should be at the end. So let me go ahead and undo what I did. That's what's supposed to be the right order. So as keyword arguments, you can go ahead and input it in any order though. I can go ahead and say pay equal to 50. And then I can go ahead and say regular hours equals to 40. And I can go ahead and say overtime hours equal to 20. That will work just fine because I'm using my keywords to specify each one of those inputs. Does that make sense?
Yeah.
So keyword arguments are very useful and very powerful. You can set it up whichever order you want, right? So again, if I don't want to hard code it, I can go ahead and have maybe input, enter pay, and so on and so forth. So in here, I probably want to say pay equal to that. Does that make sense? So we're using our input built-in function to get the user to input something, but this is probably going to error out because the output would be a string. So we need to go ahead and change it to an integer. So all of this now, which we're doing here, is the stuff that we did in here. So if we had this function ready, we could have not have to type in that all along again. We'll just go ahead and define this function, which gets a user input and changes it to an integer output. Let me copy that over to the other file. So we have a new function in there. And then it returns that. And if that's the case, I can go ahead and rather than entering this, I could say the pay is equal to what's the name of that? Enter input.
Enter input.
And that should be just good. Now I can even make my enter input to also take a particular argument. Maybe I can make it to take one parameter. That parameter would be name of input, right? If I decide to say name of input, instead of say enter value, I can go ahead and say enter. Then I'll put in the name of the input. The name of input would be whatever string I want to use. So let me copy that. Now, if I want to use it in here, it's probably going to give me an error message if I don't have an input. So it says enter input should have name of input. In here, all I have to do now is, so enter pay. And it's going to say enter pay when I execute it. So it's going to say enter pay. I'll enter it, and that's good. Which means I can also use it for regular hours, right? And then I can go ahead and say enter regular hours. Let me copy this. And I can use it as well for overtime. Say enter overtime. Now, if I execute that, you can see that instead of writing so many lines of code, let's go ahead and delete all these comments in here to make my code simpler. So just in 10 lines of code, I was able to do all of those. If I execute it, all of this is just defining my function. This is just defining my function. I've defined this function, I defined that function. Now I'm getting a variable to hold my salary. Okay, oopsie. Once I have a variable to hold my salary, I print it. So that variable is taking one function and you're having a nested function within it. So if I execute this, let me clear this out first. I think there was something I needed to fix here. Enter this. Yeah, let me put this on a new line because I don't like that. Yeah, so that will go on the new line. Execute that. Now it says enter pay. It's gone to a new line. My pay is $50. Regular hours 40. Overtime 10 hours. And it gives you your total. Looks good.
Is that what you make an hour with Python?
That would
This
probably
is
be
something
less.
else.
No, because again, this is for 40 hours. That's for a week, right? For 1 week, you put in 40 hours and 10 hours overtime. And if you get paid $10, that's how much you get. So now we've been able to use functions to make our code easier and more reusable. Anywhere down the road we want to use that enter input, we can use it and it works just fine because we're able to get a user input and it outputs an integer for us. Now it's easy for you to use that try catch or try except. Okay.
Yeah.
Because if you want to use try except, you're just going to use try except on your function.
That's why I got stuck because I'm studying this morning.
Exactly. That's why I said once we get to functions, it's going to make your life a lot easier to be able to do those.
Prof, if you expand number 4, line 4 there, There are
Yes.
two functions that we are using. Now, with the concept of the global variable, you told us in the previous classes that you can introduce a variable at any point in your code, right?
Yes.
For example, name equal John, you can put it on line 2. You can still go down to line, maybe line 13, is it?
Yes.
Put name equal John, and
Yep.
it should work. Something like, if I remember well.
Yes. So this name equal to John that we're using on line, let me make it better. On line 3 is a global variable, right?
Yes.
Which means you can use it inside this function. You can use it inside this function. You can also use it outside the function. But within this function, we have name of input. Name of input is a parameter. It's a local parameter. You can only use this bucket within this function. That's why we could use it here. We cannot use it in another function. We cannot use it outside. It's just a placeholder. A parameter is just a placeholder so that when you have your argument passed into that function, the argument gets passed to that parameter to execute. So in here on line 22, we called a function. That function that we had defined, enter input. In here, we passed an argument called pay. The argument called pay gets passed into name of input. Name of input now is going to substitute pay wherever you have it in your code. So it's going to say enter pay. We use that same function though to get regular hours. We use that same function again to get overtime. Does that help?
Yes.
But with name, you can use name anywhere. You know, we can go ahead and print out our name in here. So we can go ahead and say name has entered an input every time we enter it. And when we go into the calculate, we can also use it. Before we return it, we can say name has a particular salary, right? So let's print name. We can go ahead and say name has a salary of salary. Yes, question, Aaron.
Is it safe to say that if there is a local variable and a global variable with the same name, the code is going to look at the local first before it goes to the global?
That's going to be challenging, though. I think you might run into an error if you have that. But most of the time, you need to remember also that naming convention matters. This name is in caps, so we know it's a global variable. If we have another variable in here that's lowercase name, that's totally something different, right? So name in here could be DK. That should work just fine. But if we try to use capital NAME, we'll definitely have an error, or pretty much it's just saying now we assign this value. The value before was John, changed John, now it's going to be DK.
Okay, because that's what I was, not that I've tried anything, I was just thinking, because there are situations where you can, you might want the local variable to be different from what the global variable is, and you may want to use that local. And then there are situations where if you call a function that does not have that local, you probably want to pull the global. I'm just thinking about you.
Yes, that's totally fine. You can change the name in here to be DK, but understand that this is only going to change within this function.
Exactly.
If you get out of the function, it's still going to be John.
Yeah.
Okay, so in this case, if we want to print, it's going to say DK has entered an input, DK has entered an input, but here it's going to still be John has a salary of that. because John is a global variable. It's alive throughout the program. Here, DK is a local variable. It's alive only within this input. So very good question. All right.
Ron, my comment would be that we'll just apply simple is better than complicated.
Yes, yes. Simple is better than complicated. You definitely want to not complicate things. All right.
Use a different variable with name.
Yes, use a different one and save yourself the headache. All right. So we've gone over our time so far before our first break. It's about 8 minutes after the hour, but I think we're doing good on time because the next thing we had to do was, if simple is better than complex, complex is better than complicated. So I'll give you 5 minutes break, very short break to catch up, catch your breath, test a few things, walk away from your computer or your phone. And then when we come back, we're going to look at return. I know we've talked about return, but we'll still look at return a little bit. And then we'll look at a few practice questions. Sounds good?
Yeah, it amazes me that I can write 5 lines of code.
I'm glad that we're all
Aaron, what this guy is doing, I tell you, anytime like this keyword argument, I used to call it quacks, right? Anytime I look at the code and I saw that thing, I'm like, what is it? What is it? But thank you so much. I can appreciate you enough. I can even stand the side of Python code now, like to even look at it and say
this is the fundamentals. Once you're comfortable with the fundamentals, nothing is gonna scare you. Nothing at all is gonna scare you. All right, so let me go ahead and put 5 minutes on the clock, and then we'll go from there.
Thank you.
You're welcome.